Hello friends, welcome to Brain Scoop channel. This is my new video and our today's topic is modes of ultrasound and Doppler imaging. In ultrasound, there are two main imaging modes. The first one is the grayscale imaging and the second one is the Doppler imaging. In grayscale imaging, there is A mode, B mode and M mode. And in Doppler imaging, there is continuous wave Doppler, power Doppler, color Doppler, duplex Doppler and pulse wave Doppler. Let us first start with the grayscale imaging. So in grayscale imaging, there are three modes. The first one is the A mode, which is the amplitude mode, the B mode, which is the brightness mode, and the M mode, which is the motion mode. Let us first talk about the A mode imaging. A mode, simplest form of ultrasound imaging which is based on pulse echo principles. A scan can be used for measured distances. A scan only give one dimension information, not so useful for imaging, used for echoencephalography and echo-ophthalmoscopy. Here is a graph of A mode. In A mode, echoes are displaced as spikes projecting from the baseline. The baseline identifies the central axis of the beam. Spike height is proportional to the echo intensity, with strong echoes producing large spikes like this. A mode reveals the location of echo producing structures only in the direction of ultrasound beam. A mode displays are not found on most imaging systems used today. The concept of A mode is, however, useful in explaining how pixels are obtained from scan lines in B mode imaging. Now let us talk about the B mode. The B mode stands for brightness mode, or the B in the B mode stands for brightness. B scan gives two-dimensional information about the cross section, generally used to measure cardiac chamber dimensions, assess valvular structures and function. So B mode produces a picture of slice of tissue like this. The transducer is like the handle of the saber with the ultrasound beam as a blade. The blade images a sagittal section when it cuts through the length of the body and images a transverse or cross section when drawn from side to side. So in B mode, real-time grayscale B mode display, a two-dimensional display of ultrasound. To generate a two-dimensional image, multiple ultrasound pulses are sent down as a series of successive scan lines, building a 2D representation of echoes arising from the area being scanned. When an ultrasound image is displayed on a black background, signals of greatest intensity appear as white, absence of signal is shown as black, and signals of intermediate intensity appears as the shades of gray. Here it is. B mode images may be displayed as either static or real-time images. In static imaging, the image is compiled as a sound beam is scanned across the patient and the image presents a snapshot averaged over the time required to sweep the sound beam. Next is the M mode. M stands for the motion. This represents movement of structures over time. M mode is commonly used for measuring chamber dimensions. This is analogous to recording a video in ultrasound. Next is Doppler imaging in ultrasound. It is a general term used to visualize velocities of moving tissues. Doppler ultrasound evaluates blood velocity as it flows through a blood vessel. Blood flow through the heart and large vessels has certain characteristics that can be measured using Doppler instruments. Blood flow patterns. The blood flows in two patterns. First one is the laminar flow and second one is the turbulent flow. In laminar flow, layers of flow are normal, slowest at vessel wall and fastest within the center of the wall. In turbulent flow, obstruction disrupt laminar flow, disorder directions of flow. So, how is the blood scattered by ultrasound? The composition of the blood causes important differences between the Doppler signal generated by blood and that generated by solid moving structures. Sound reflection from solid structures is usually referred to as the specular reflections. Specular reflections implies a nice smooth surface. The wall of the blood vessel is relatively smooth, whereas the red cells are not continuous and act as rough surfaces. Ultrasound encountering blood is not reflected, it is scattered in all directions. And this scattering is referred to as Rayleigh-Tyndall scattering. What is Doppler effect? Apparent change in the received frequency due to a relative motion between a sound source and a sound receiver. This is the Doppler equation where Doppler frequency is equal to 2ft v cos theta upon c, where fd is the Doppler shift, c is the speed of the sound in tissue, ft is the transmitted beam, v is the velocity of the beam, and theta is the angle of incidence between the ultrasound beam and the direction of the flow. Higher Doppler frequency is obtained if velocity is increased, beam is more aligned to the flow direction, higher frequency is used. What defines a good Doppler display? The first one is the no background sound, clear audible signal, and accurate display of velocities. There are types of Doppler ultrasound. The first one is the continuous wave Doppler. Use different crystals to send and receive signals. One crystal constantly sends a sound wave of a single frequency, the other constantly receives the reflected signal. What is the advantages of continuous Doppler? So, the continuous wave Doppler can accurately display flow of any velocity without aliasing. Di- disadvantages of colored wave sorry Disadvantages of continuous wave Doppler: samples everything along the Doppler line, cannot position the Doppler to listen at a specific area along its path. Next is the pulse wave Doppler. Produces short burst pulses of sound, uses the same crystal to send and receive a signal, whereas continuous wave Doppler uses two different crystals to send and receive the signal. This follows the same pulse echo technique used in 2D image formation. Advantages of pulse wave Doppler: can sample at a specific site along the Doppler line. The location of the sample is represented by the sample volume. And disadvantages of pulse wave Doppler: the maximum velocity which can be displayed is limited. The signal will always alias at a given point based on the transducer frequency. So the comparison: in colored wave Doppler, accurate measurement of high velocity and poor range resolution, whereas in the pulse wave Doppler, there is good range resolution and limitation of maximum velocity. In pulse wave Doppler, only one crystal is used. In continuous wave Doppler, two crystal, continuous transmission and reception. Okay. In pulse wave Doppler, unable to measure high velocities accurately, and in continuous wave Doppler, able to measure high velocities accurately. In pulse wave Doppler, there is range resolution, and in continuous wave Doppler, there is range ambiguity. Next is the color Doppler. Utilizes pulse echo Doppler flow principles to generate a color image. Image is superimposed on a 2D. The red and blue display provide information regarding direction and velocity of flow. Used for general assessment of flow in the region of interest. Gives only dissipative or semi-quantitative information on blood flow. Here is the one is the pulse wave Doppler and it is the colored wave Doppler. If you have any questions regarding this video or any of the videos, please comment down in the comment section. And if you like this video, please like and share. And please subscribe my YouTube channel and press the bell icon and never miss any update. So that's all for today. Thank you.